So, have you ever thought how the electricity which is generated in a generating station reaches our homes? The answer lies in the grids. Grid is nothing but interconnected network of generating stations, transmission lines, switching substations, and the distribution substations. So, today we are going to talk about one of the interesting topics in electrical engineering, that is smart grids. So, smart grids are powering the future of electricity and they are going to be important in upcoming future. So, what is a smart grid? It's an advanced electrical grid that integrates digital communication control technologies, which is enabling two-way interaction between utilities and consumers. It transforms the traditional grid into intelligent, responsive, and efficient system capable of adapting to real-time energy demands. So it has a digital integration, advanced sensors and automation technologies throughout the network. Then it has two-way communication protocol where utilities and consumers can exchange data bidirectionally for optimizations. So here consumers can also integrate and communicate with the grid in order to optimize the power consumption. Then it has intelligent control. Automated systems respond dynamically to changing grid conditions. Then why smart grids matter now? There are two factors. One is global driver and the second real world crisis. First, we will see the real world crisis which happened in 2008 Northeast blackout in the US. Here, due to blackout, 55 million people across 8 US states were affected because of critical vulnerabilities of outdated grid infrastructure. So smart technologies could have detected and isolated the failures automatically. Therefore, we need smart grid now. Then what are the global drivers? Rising electricity demand which is exceeding the supply capacity. Then integration of renewable energy such as wind and solar. The need for reduced carbon emissions and climate actions. These are the factors why smart grids are becoming more and more important. Then what are the core technologies powering smart grids? The first is advanced metering infrastructure, which we call as AMI. The advanced metering infrastructure shows real-time consumption data. It can collect and analyze the real-time consumption data. Then it has smart sensors and phasor measurement units. The phasor measurement units provide complete grid observability. Then automated distribution. It has rapid outage detection and self-healing response. Then secure networks. Cyber resilient communication ensures data integrity and secures the grid network. Then what are the key features and benefits of smart grid? First is consumer empowerment. The real-time energy uses insight enable informed consumption decisions and cost savings. And second is demand response, which programs reduce peak loads and electricity cost by shifting consumption pattern. So in this demand response, the peak load can be shifted to the lack of load so that the consumption patterns can be balanced, which reduces the load on the grid. Then self-healing grid. Automatic fault detection and isolation minimizes the outages and restore service quickly. Then renewable integration. Renewable integration means incorporating solar and wind power into our grid. It has seamless accommodation and distributed energy resources, including solar panels and electrical vehicles. Then what is the real world impact on consumers and environment? First would be smart homes. They are optimized energy use which reduces bills and carbon footprints significantly. Then electrical vehicles. The act of mobile batteries supporting grid stability during peak demand periods. Here the point is very important that electric vehicles can act as mobile batteries. We can charge in peak hours so that it provides stability during peak demand periods. Then dynamic power shifting. Utilities shift powers efficiently, reducing dependence on fossil fuel generation. Then the time of use pricing. Off-peak pricing encourages consumption shift, easing grid stress and saving money. Then what are the challenges to smart grid adoption? The first and the most important is investment barriers. Substantial upfront costs in ICT infrastructure, equipment, and skilled workforce development is required. And second would be cybersecurity threats. Increased connectivity creates vulnerabilities. Robust encryption and monitoring is essential to protect critical infrastructure. And regulatory gaps. regulatory gaps, which are inconsistent frameworks across regions, impede market participation and innovation scaling. Then, rural connectivity. Underdeveloped regions lack infrastructure access, creating digital divides in energy access. So, what are the future landscapes? The first would be near term artificial intelligence driven grid management and Internet of Things integration into smart cities. In midterm would be microgrids and advanced energy storage solutions, which enhances the resilience. Then the vision for 2035 can be global energy interconnection connects continents for clean, reliable, and energy sharing. Then, what are the long term future landscapes? User centric, fully decentralized energy system prioritizing sustainability. Then, here is some case study about the ERCOT crisis in 2021, where extreme winter weather in February 21 caused cascading failures across Texas Electric Reliability Council of Texas, that is ERCOT grid, leaving 4.5 million people without power during freezing conditions. This was the problem because of not having a smart grid. Insufficient winterization and limited renewable integration contributed to the collapse. Then there was no real-time monitoring, there was no demand management, and there was no distributed resources. So this happened in 2021. So in today's world, embracing the smart grid revolution is the solution for avoiding such blackout situations. Smart grids represent an essential transition towards sustainable, efficient, and resilient energy future. They empower consumers, seamlessly integrate renewable resources, and dramatically reduce environmental impact through intelligent optimization. Then, how it enhances sustainability by enabling high renewable penetration and carbon reduction targets. Then, how it ensures resilience. It has self-healing system and distributed generation enhances reliability. Then, the collaboration, which requires united efforts across technology, policy, and society. So together we can build a smarter, cleaner, and more reliable power system for generations to come through these smart grids. So smart grid is an evolving technology in electrical engineering field. So in this way we have seen how smart grids work and why they are important. Thank you.